this word problem says a radio station emits a signal at 105.2 megahertz. What is its wavelength? So pause, try to get your answer, and when you're ready, double check. Let's write down what we're given. So we're only given one number, 105.2 megahertz. So hertz means that this is a frequency, and we can write this as 1.05.2 mega is also 10 to the 6 hertz. And now we're trying to find the wavelength. So here, this is radio, so this is for electromagnetic wave. So the equation is pretty simple. It's the speed of electromagnetic wave, or the speed of light, is going to equal the frequency multiplied by the wavelength. And we want to get the wavelength, so let's divide both sides by the frequency. And so the wavelength is going to equal the speed of light divided by the frequency. And so that's going to equal 3 times 10 to the 8, and divided by the frequency, which is 105.2 times 10 to the 6th, and that is going to equal 2.85 meters. Now try this one. A radar sends a signal to an asteroid that is and it takes 20 minutes for the signal to return. How far is the asteroid from the radar? So go ahead and pause, try to solve this, and when you're finished, double check your answer. All right, let's write down what we're given. So we're given only one number, 20 minutes. So that's going to be a time. So, and we're trying to find distance. So we're trying to find, let's call it x. All right, so first, let's go ahead and convert the time into seconds. So you have 20 minutes. Let's do a bar. Minutes is on top, so put minutes on the bottom and then cancel. And we're going to go from minutes to seconds. And 1 minute has 60 seconds. So the time is going to equal 20 times 60, or 1200 seconds. So now let's draw a picture to see what's happening. So this is the Earth, and then there's a radar here, and there's an asteroid. So what's happening is that the radar sends a signal. The radar is going to travel at the speed of light c, and it's going to travel this distance x, and then it has to bounce back and return to the radar and travel that distance x again. And it's going to do all of that in some time t. So because this signal travels over the distance twice, we're going to use the equation. The speed of light, or the speed of the signal, is going to equal 2 times the distance divided by time. And next, let's go ahead and solve this equation for distance. So multiply both sides by t, and cancel here, and then also divide both sides by 2, and you cancel there. And then so the distance is going to equal the speed of light, or the speed of the wave, multiplied by time divided by 2. And so that is going to equal 3 times 10 to the 8, multiplied by the time, which is 1200, and divided by 2. And that's going to give you a distance of 1.8 times 10 to the 11 meters. The next word problem says, what is the energy of blue light that has a frequency of 7 times 10 to the 14 hertz? So go ahead and pause, try to get your answer, and then double check. So let's write down what we're given. We're only given one number, and that's 7 times 10 to the 14 Hz. So we're given a frequency. and we're trying to find the energy. So here, what this corresponds to is that you have a photon or packet of blue light. And the packet of blue light has a frequency f, and we're going to find the energy of this photon. And the equation is just the energy is going to equal Planck's constant multiplied by the frequency. And so we just have to plug in here. So the energy is going to equal Planck's constant, which is 6.63 times 10 to the minus 34, and then multiplied by the frequency, which is 7 times 10 to the 14. And that's going to give you an energy of 4.64 times 10 to the minus 19 joules. So that's the energy of one photon of blue light at that frequency.